All right. Welcome, everybody, to my talk about TypeScript patterns for better React apps. First of all, hello. Do you say hello? Hala, Malmo. It's my second time here, and actually my first time here in Øredev. So yeah, thank you for having me. This is really nice to be here in this group of super awesome people. And yeah, I'd like to introduce myself really quick. My name is Reyes. I'm also Glenn Reyes, but without the E's or without the vocals on all the socials, so Glenn Reyes. You can find me also on glennreyes.com through my website. I'm a software engineer, tech speaker, and workshop instructor, and work currently for myself. Now, we have a lot of topics in this conference, but in my particular talk, we want to talk about TypeScript. But more specifically, we want to focus in this talk more about typing in React. So to start with, I'd like to reflect on the history of typing in React. So personally, when I actually first got into React, I think it was around 2014. And by the time React was open sourced about a year ago, like in 2013. And the interesting thing is that by the time it was open sourced, it already came with some sort of typing with prop types that you were able to type your props with on runtime. And worth note also is that 2013 was it first open sourced, but it was already used in production by the company behind it, Facebook, back in the day. Today it's called Meta. And it has been actually 2 years in production already. What's interesting is that by the time I was learning about React, like around that same time, there was some sort of static type checking release called Flow. That's also coming from Facebook. And that was actually also, I think, where about 2 years later, where I got into static type checking as well. Now, about 2012, TypeScript was released, which was about 1 year after React was released. And I found out about TypeScript, I think, about 2 years later as well. So that was around 2016. And I also learned about other ways on how you can actually write better and safer code through, for example, Elm or OCaml, which was quite interesting because they also focus on other things like expressiveness or safety, which allows for simple and type-safe code leveraging both JavaScript and OCaml for Reason, for example. So the growth, when we talk about growth about TypeScript, when I started adapting TypeScript, which was around 2018, so 4 years after I actually learned about React, that's a time where people also kept moving everything to TypeScript. So you were seeing a lot of libraries, a lot of frameworks actually start adapting and start embracing the type checking. And basically support skyrocketed completely. Now, what about beyond today? So maybe TypeScript takes over, or JavaScript becomes like super low level, so kind of like machine code or something like that, or maybe just AI takes over, and we don't care as much anymore today. Now, today we want to focus really about TypeScript, and yeah, from the beginning. Angular has been early on and until today tightly integrated with React, and so has been Vue, and specifically Vue 3, which was released September 2020, which has been completely written in TypeScript. So TypeScript has been tightly integrated with with Angular and Vue, but interestingly, not with React. And even the way you want to type React is actually very unopinionated. You can write it in both. You can write both prop types actually and TypeScript, and maybe even Flow on top of that. It can also be completely anything else. And we have seen a lot of projects, like for example, grade starters and boilerplates, like in the past, create React app, created in JavaScript, and then basically afterwards adapted TypeScript. And now, very popular Next.js was completely rewritten in TypeScript, and you've seen, or you see now, the growth of Remix, which has been around since 2021, was completely from the ground up written in TypeScript, which is really awesome. And in fact, if you look into some React source codes, you see like JavaScript files all around. Some of the files that you see here, I actually annotated with Flow, which again is coming from Meta, that has some sort of static type checking in there. But the rest is like all over in JavaScript. So TypeScript types for React are purely driven by the community, and there is a project on GitHub in Definitely Typed where you have basically typings that is coming from the TypeScript community, and it didn't actually take long until they added the typings to React once it was open sourced, which is a great thing that is not driven by a company or by like a single entity. And I personally like that it's not like too tied to TypeScript, because it's super universal, because there might be like a new solution, like a typing solution in the future that we can easily adapt to. Now let's talk about the actual content of my talk about TypeScript patterns. And first of all, I'd like to kickstart that with like Boolean props, which is the simplest prop you can ever do. And we all know they are supposed to be for only 2 states, and not any amount of state, but like exactly 2. For example, if you have like disabled, and then if you don't have that, it's enabled, or you have checked, and if you don't have that, then it's basically not checked, and so on. Whereas if you have a kind of variant where you could have like actually end states, like more than 2, it can be quickly odd if you use it like this and add another one, what to do now, all right? So, but with TypeScript, it's actually possible to use it that way by writing discriminating union types. So even though you're not supposed to do that, with TypeScript you can actually still do that. So if you do discriminating union types, you'll still be able to get some sort of errors that is telling you that like primary and secondary is not assignable simultaneously. But of course, every one of us probably that has been using TypeScript for quite some time knows there is basic string literal union types, which is the more common way. So it's basically a selection of string literals, and it allows us also, of course, less code compared to discriminating union types. Some interesting difference that I've seen between these is that if you try to pull up the IntelliSense or auto suggestions on your editor, you can actually see some difference here. So for example, using this variant or with the primary and secondary example before, you can see that actually if I'm just using it as a prop, it displays me like a lot of other props here in my suggestions as well, which is kind of cluttered. So what I actually want to see only is the actual selection that I want by the string literal unions compared to the discriminated union types. Now, how about enums compared to all of these? So enums is very similar to string literal unions, yeah. But there are some notable differences that comes actually with enums, which is that the enum type is distinct. So what does it mean? So if you have, for example, 2 enums which have the same value, like red value, for example. So we have color and fruit, and you want to compare the red value with fruit, apple. then it's going to be not the same, even though the value is the same. So that's something what enum can provide us. So, if you try to like enumuize everything, chances are that your import statements are also getting cluttered. So you're gonna increase in import statements with enums that you may want to import from somewhere else. So and yeah, one difference also when you use enums, probably it's not very obvious, but it actually adds quite some overhead to your compiled code just for adding, for example, just a simple enum. So now imagine you have like a very complex enums, then it probably adds even more code. Whereas compared to if you would have only string literal unions, it's basically just a single line of code in your compiled JavaScript bundle. Now, we have seen Boolean, unions, and enums, which are great for passing component states. On that note, I want to add something like this. So sometimes you may want to write something as a custom component. So when do custom components come in handy? Should I create primary button, or should I just do button variant primary or something? So when do you decide that? So I have thought about this for quite some time, and for me, I think what makes sense is when you create custom components that have some sort of action inside. So, for example, if you have a submit button that you want to add with some logic, or for example, or with some default states when you pass a loading prop to it or a disable to it, that derives from some context of an upper component. And I think it has less to do. It should have less something to do appearance-wise. So it should be identical to your primitive components that have more stylistic focus. Now let's talk about components with HTML attribute types. So in React, there is a variety of ways how you can add HTML element attribute types to your actual components. And in the beginning, it could be like very daunting because you don't really know what the differences between all of these are. So they appear to be like every one of them appear to be like the right one. But it can be actually daunting to find out which one you actually really need. So I'm going to explain to you every one of them in detail. So first of all, we have react.html attributes, which does not include basically all the types you may want to need. So they are supposed to be more for typing the components that have like shared types. So probably most of them will have some sort of ID or something. So for example, if you try to apply HTML button element or want to use the type prop of that, it's not going to be typed because it's existing, and that's something that is not available to all components. The opposite of that is basically react.html props, which is an alias to all HTML attributes. Which provides basically super accurate types, but not enough. So, for example, if you have, again, the HTML button element, and you try to find out what the type of a type is, you probably expect a string literal union of button, submit, reset, and undefined. But what you instead get is just string, so which is not super accurate enough, but it's still okay-ish. And the better alternative, or one better alternative of that, is using JSX.intrinsic elements, which is really good, but it errors when you try to inline it. So for example, if you want to extend it from an interface, and it's not going to allow you. But there is a workaround what you can do, which is basically wrapping it with the TypeScript utility type non-nullable. and then you'll be good to go. But there is also button HTML attributes, and that you can pass a element with, which does basically the job really well and is really, really good. But compared basically that with component props, which is the actual real winner, there is no real difference, but you write less characters with component props. So there is no real reason why you should write more. So what you actually looking for, if you want to have like very correct types to your components that derives from HTML elements, or component props, and there's three of them. What the TypeScript library of React basically recommends is using the ones below, component props with ref and without ref, to be very explicit whether you use a ref or not. But you will be fine also with the first one if you are not strict about whether it should be or whether it will be wrapped with a ref or not. And on that note, actually, so ref is confusing right now, and there is chances are that like wrapping some component with forwardRef is going to disappear at some point, some later version of React. Now let's talk about typing React, the type of React function component. So what it basically does is it attaches a couple of properties to our components, which are great and useful for tooling and provide more contextual details to the component. And that's been actually different in the past. I think React 17 back then they used to implicitly add a children prop to the component, but it's not the case anymore today. So here is an example how you can actually use that. So for example, if you want to attach something with a display name, that can be useful if you, for example, like have an anonymous function that doesn't really have a name, and if you want to look it up with, if you want to look it up in the React Dev tools, they actually show up with a proper name, or if you want to debug with some third-party library, that's super useful. So nowadays, we may want to deal with React Server components. So yeah, quick summary of what these are. Basically, these are components that never gets to the client. So they are running in the server, and they do not have like some complex state or some like basically any state, and they basically just provide you the HTML and outputs it right into your document. So React Server components basically are, as I mentioned, components that run on the server. Then they actually also can be written async and include promises. Cool thing about what you can do with that is you can actually await and fetch something right into the server and then basically apply it with some data. And the typing of that used to be incompatible with previous TypeScript versions. But since TypeScript 5.1, it's possible to have the components returning a promise, which is nice. And if you consider using React Server components, make sure you're at least TypeScript 5.1 to have full compatibility with TypeScript and with your TypeScript compiler. Now, let's talk about reusing types and interfaces. I think reusing interfaces from components or from some sort of other things are a great way of avoiding generally duplications, which is less maintenance overhead. And personally, I like to export only when I consume it, where I consume something elsewhere. And then basically you have the question: should you use utility types or write out basically some simple types? So in this example, we have, for example, like set is open. Should I just use arrow function, or should I export this complicated type that nobody basically understands what it really does? React.dispatch and then React.setAction and then some like a wrap generic, which looks weird at some point, and there is libraries or there is like cases where it's even more complicated. And I think it's about readability versus accuracy. So to answer this question, I think it depends. And personally, I like actually this accuracy, but maybe I'd like to keep utility types as well until coworkers start to complain how unreadable the code gets. And so there is no fits for all solution, but I generally like to prefer reusability and keep simplicity on a case-by-case basis. Now let's talk about compound and polymorphic components. To explain a little bit, so compound components are basically components composed together where the customization is managed by the past component itself. So for example, if you have icon and then an icon prop where you pass an entire component, you customize this icon within the download icon component itself. For example, you apply it with some size or you apply it with some color within the download icon component. Whereas with polymorphic component, you may want to, or you may have the customization on its primitive. So instead of, you pass the icon as a component instead of as an element, and you pass the icon, the customization of this component with size or maybe color. So in this case, I only have size. And yeah, on that note, actually a great example of compound components merging props together is this thing by Redux UI called slot. So basically what it does is if you have a component that supports or that it has slot support, it also accepts an as child prop. And what happens here is the trigger, which I think should be a button, and you have this as prop as child prop, and then within you have an a tag or a link passed. It basically uses this a link as an element and merges basically the props with the trigger together. So this means that the click handler is being applied to this a, and so on. So here's basically a simple mock implementation of this. So the slot component basically that renders the child and merges the props together. So I think what's worth to note here is that within this if condition, you see return state returning a React clone element, and basically copies the child and merges the props, children props with the parent props together. And on the button, what you just basically want to do is when as child is set, you may want to use this component slot, and otherwise the component that you previously or you want to have by default, for example, like in this case, a button, and then basically render that. So polymorphic on the other end are a great way to generalize components of elements or components. And similarly, what we have seen here is that we also have a prop where we define basically the element, and the implementation actually of that is not trivial to create a component with strict typings, but I think essentially what it does is you call or you do again here as being the component or being some sort of element, and then basically return this component. And yeah, what this basically under the hood is doing is basically just calling React.create element and applying that with the props. Another thing what you can do in React is basically writing React components with generics. So it basically allows you to pass generic types directly to your JSX component elements. So how is this useful? So I think it's great if you have hooks or something that needs more details about like what values you're dealing with. So I had the case where you have some sort of form provider, and you may want to provide the hook. So in that case, it was a React hook form. You want to provide that with values or typings of values. And one way I was able to do that is by passing the form provider with create post form values, and then getting it from there into the use form hook. Now React.forwardRef. Basically, there are cases where you may want to forward your ref into your component, and typing components wrapped in forwardRef is actually pretty straightforward. So you have you have two generics where you or two parameters in your generics. So where you pass your element and your props, and then you're good to go. But it will become problematic if you want to type a component that has actually generics. So how do you do that? Now, there is multiple ways how you can do that, and I think the most popular way is by just type assert it, or just override it, or maybe just using just any. And but my favorite way on doing that is basically augmenting forward refs. What happens here is basically TypeScript has a feature which is called higher order type inference that allows basically propagating free type parameters onto their outer function. And that's basically what's happening here. And what this allows you is basically instead of passing the React forward ref with some generics, you just pass the generics onto your props and type the ref like this with React.forwardRef and pass the element. And then you'll be ready to go. So I think this article is brilliant, explaining the different options all in detail if you're interested in learning about typing forward refs or complex forward refs. So if you ever hit in some problems typing in forward ref, definitely think about this, and it potentially could help solving your problem. Now let's talk about typing React.context. So here is basically how you type context with default values. If you have default values, you may want to pass it, of course, with some default values. In that case, I have a team context that I provide with some team context types, which is a union of light and dark. And then you have your provider, where it also comes with some default values. So it may come with some state, and then you pass the value to your provider. And then after that, you'll be just ready to go. So you just use your hook, use context, and then the types will come out automatically as you would expect. Whereas if you don't have like any default values, you may want to type it like this. So you have still your type, but you want to make it with a union of null, and then you initially have nothing. So it's going to be null. And then I think what's worth to note is that since something is coming, if something is potentially null, you may have some cases where you just still you still expect some sort of data once you access or once you consume the context. And on these specific cases, I think it's useful to create some custom components where you do these checks within the custom components and error it when there is no context set. And yeah, it's a great idea to do that with via custom components, so that you don't have to do that every time. Now, there is another way in how you can do components more, more expressive. So overload function components. So this is a great way, similarly to discriminative components, for using props that are related in conjunction. So for example, if you have a data display component that basically just displays some data, whenever you want to have that data displayed as a currency, you with this, what this overload function components allows you to do is basically it just then enables you the currency prop, and just then the value will be number. And same thing or similar thing if you would just expect some sort of like a unit, for example, if you have meters or if you have I don't know, pounds or whatever, you expect unit to be string and the value also like be a number. Whereas if you would just expect some plain text, then probably value will be just only string. Then you often have this discussion whether you should be using type or whether you should be using interfaces for your for typing your React props. So generally, types are more concise and I think easier to read, and it's easily possible to just override it with some intersection typing. But you can't add additional members where you can only do that with interfaces. So interfaces can extend actually other interfaces, which makes it a bit safer than intersection types. And yeah, these are like interfaces are also great for enhancing third-party libraries, which makes it again type like safer. And yeah, one thing about interfaces is it's actually like you cannot like override it as you can do with the type, which is like both good and bad. But my personal experience with both of these is that we had a project where we had type all over, and we had the case where suddenly if you just hit save, it took like more than 5 seconds until it actually saved. So you were seeing in your VS Code editor if you hit save, and then it basically blocks you from doing anything because there is like everything froze until like 5 seconds has gone, and then now it's saved, which was quite not a good experience. But what we found out is that if what we have done is we have refactored some of the interfaces, like some of the simple types that we have into interfaces, and then we saw that it suddenly was gone. So we didn't really know where it was coming. And with some further research on that, is that we found out that actually it reduces some computational work by just using interfaces. So therefore, my take is that whenever possible or wherever it's not much of a hassle, prefer interfaces for faster TypeScript compilation in your editor. It's very easy to do that. There is some linting rule that can basically autofix that, automatically do that for you, which is really, really neat. And yeah, on that note, I also encourage actually to do type annotations in general, especially in your function return types. Because it just reduces work for your compiler, and basically all the details that I've just mentioned are on the official TypeScript repository in their Wikipedia docs, which is quite interesting read that I think is still underrated to know. Although quite straightforward and trivial, I think still also what's also very underrated is how actually commenting types can help your mates to be like super more productive to do that. One specific example I'd like to show you is I'm a big fan of day.js, and all the time I'm using that, and specifically the format function. I never remember the shorthands for some like for displaying some dates in a nice way. And the good thing is, every time I try to call or try to make the function call, it is showing me a link to the docs, and on these docs I can see the actual shorthand codes, which is super neat. So by just doing some thorough commenting on your types. Like even if you deprecate something, like this is super useful for developers or for your teammates, that you can quickly see that something is like strike through, and then you can just replace it with the actual thing that you want to deprecate, replace it with. So yeah, definitely do commenting types. Of course, I cannot do a TypeScript talk without mentioning our basically favorite type. So yeah, it's your friend, but it's also at the same time not. Of course, we cannot always avoid having any. So and specifically, if you use or if you have some sort of fetch happening in your code, of course the response is going to be just any. And by the way, if you try to type it with something with some response, it's not going to be that response. But it's basically just cheating. But what you can do, I think my favorite way of handling these kind of things is to do actual runtime types there. And my favorite way to do that is with a library called Zod, which basically what it does is basically you provide it with some schema, or with you define it with some sort of typing. And then decide when or how you want to parse it, and on parse it either errors or not. So, but if it doesn't error, so if it really if it's correct, it will respond to you with the exact types that you would expect. And of course, I need to mention, besides any, there is a lot of other bad things. Type assertion or typecasting, and the non-null type assertion with the exclamation mark. Basically avoid them all if possible. So here is what I mean by type assertion or typecasting. If you anytime you do as number, it is code smell. And yeah, similarly, it doesn't help if you just do the exclamation mark. It's very similar. It's just you're basically just saying it is there instead of it is maybe there. And again, here you may want to leverage some sort of runtime parsing, of course, but also for the type assertion and for typecasting, there is ways to avoid that by doing type guards or type checking functions. So an example would be if you leverage like type of create.data. If the data is responding with or is coming with a number, then you basically want to you may want to use data and otherwise something else, right? I've talked about a lot of patterns, and it's not that we have to remember everything every time we code on React, but there's tools that can help us with fixing like super low-hanging fruits automatically, and which makes us, which makes it really, really easy to work with. So automate where possible, and with that being said, like great tooling keeps your code base clean without the hassle. And I'd like just there's a few tools that can help you with that, and you may probably already use 50% of these, but I'd like to put it up on the screen anyway. So super important, TypeScript ESLint, super helpful. It comes with a lot of auto-fixable stuff. I haven't put it there, I guess, but there is also like super neat prettier plugins that help you with organizing your import statements. So check out import or prettier plugin import, and then you will find something. And yeah, the other ones are basically just helping you with bundling it together correctly and nicely, and and more utility types that you may find super helpful for you. So just a reminder that tools are just here to help and not to make things more complicated. And this is like super important. So the tools are not here that you just may want to adapt at a later point because you will have to ship your product first. I think it's super important if you just set it up in the beginning, like right from the beginning, and of course adapt improvements later over time that you may have seen. But it's nice to have like a good foundation of your tooling together that can actually ship you this entire thing faster. Now let's. I think this is one of my last points I'd like to talk about, which is configuration. So TypeScript comes with tsconfig, and I think this is like the most popular configuration that you may want to set. So strict to true, which comes with a lot of things that is really nice. But there's a lot of other things that is not included in this strict flag, and that you may want to consider to use. So for example, allow unreachable code. So may have some code that is actually not reachable. Or my favorite example here, actually, no unchecked index access to true. What this is actually doing is that, for example, if you have a list of numbers, and what TypeScript most of the time is doing is that it's inferring some array of numbers, the type into a number of array of numbers. And what with this flag set, what it's instead doing is that it puts an undefined as a union into it, because for the reason, so for example, if you want to access, or if you have an empty string, and for some sort of reason this type is an array of numbers, and you want to access the first one of this empty string, it's undefined, and it's actually incorrect, and this type actually makes it correct. But it could be cumbersome if you just adapt it later on a big project. But it could potentially save you, or it could potentially make your code more reliable. Now, one last thing before we wrap up. Remember that the types aren't there, to have fun with your arrows because it's so unreadable, or because your boss is saying, "Oh, you should use TypeScript because it's so much better." So TypeScript is basically here to create more confidence with your code. And the TypeScript patterns that I showed you for your React components are just here to help you decrease the maintenance of your components. So yeah, that's everything I have. Basically, yeah. I hope you have learned something out of it. Embrace the power of TypeScript, but don't take it too far. You can find all my slides, all the links that I've referenced in my presentations in this link, in my link tree, or you can scan this QR code. That's all I got. Thank you very much. Enjoy the rest of the conference.